All right. I can't say welcome, friends. That's a statement that only Jim Nance of CBS can use. He uses it for golf most of the time. All right. And he uses it for the masters. And I'm going to say that we are going to master the periodic table right here. I love the periodic table. It's one of the cooler things that we get to talk about. Um, but basically, we've got a few different areas of expertise. It's going to go through and it's going to say, where on the periodic table am I? What am I best known for? These are the properties. So, oh my gosh, that Wadsworth guy, he's making me really learn these properties. Yeah, so we're going to go through and for the next, I don't know, 5, 10 minutes, we're going to go over some basic properties of these guys. I have this in conjunction with the reading that you've already done. I know that we're throwing a lot of words at you. I know that we are teaching this to all of you guys. And I know that at times the periodic table can be a lot of information. And the cool thing is, students your age in this time in the world, we get to learn how to process information. Back in my day, we didn't have cell phones in our pockets. I didn't have a Chromebook. I didn't have the ability to go through and look up the atomic mass of beryllium. I didn't have the ability to go through and think, okay, what are some chemical formulas? I'd have to look them up. What right now we're teaching you guys how that we can use this periodic table for our understanding. So let's go through and let's fill this one out together. Transition metals. That is going to be these guys, and I'm going to go through and choose different colors today. Right here, you'll see that this is a colorful chart. It reminds me of our art room. And you know what? I'm just going to go for broke. Right here, I'm going to choose this yellow. And we're going to go for transition metals. Those are these right here. And I want to make this a little bit thicker. A little bit thicker, okay. And we're going around. Transition metals are going to be this red section. So transition metals. Let's go through and let's give some this basic group. They are group 3 through 12. And if we look up here, this is group 3 through 12. Let's get some properties. So we'll go through and I'm going to type this one out. Transition metals. So this is the middle of the P table. These are metals. What are they known for? Well, some properties, and these are some really big properties. They're really good at conducting electricity. Conduct electricity. They're really good at conducting heat. Some other ones that it says right here, and I've got my sheet up just like you guys. A very common example of these transition metals is going to be our buddy iron. Iron, we like to make this into steel. But if we also look at other transition metals, copper, silver, gold. And I always like to think about how copper, silver, and gold are all in this column 11. All in column 11. And if you think about it, different columns, and this has been shared with you before, and if you haven't heard it before, every single thing in a section, if you are in this section, you are going to be one type of element. If you're in this section, you'll be one type of element. We mentioned a week or so back, this one is the noble gases. Well, all of these guys are going to go through and have different properties. So back to where we were at, copper, silver, and gold, all being these precious metals, they're all found in this column 11. So transition metals, they conduct electricity, they conduct heat, and they are metals. Okay, scrolling down, let's go to our noble gases. And I already mentioned that. Noble gases, we're going to choose purple. Why? Well, purple is a royal color. And right here, these noble gases, these are the ones that don't react. These ones don't react. And why don't they react? Because their valence electron shells are filled. So right here it says, where on the periodic table am I? This is the far right of the P table. What are they best known for? They don't react. In my example where I said we really want to go and form bonds and share electrons, these guys don't. Why? They have a full set of valence electrons. So full shell of valence electrons. They don't react, and they are usually gas. If you really want to know what they do cool, these are like the neon lights. We can run electricity through them. And if you remember from like fourth grade when we learned about states of matter, one of those plasma where, Mr. Wadsworth, what about plasma when we teach solid, liquid, and gas? These are plasmas. They're pretty awesome. But noble gases, they don't react. And that's because their valence electron shells are filled. Now we're going to scroll down here. We've knocked off two of them. We've got our alkali metals. We love alkali metals, and I haven't shown it to you yet. I plan on doing that at a different time. And you know what? In different years, maybe I will have shown it at this point, and that's okay too. But the alkali metals are going to be these guys on this first section or this first column. And I haven't said it yet, but what's really cool about these ones is they blow up in water. So where am I? We're going to say this right here. I am on the far left side of the P table. The pattern that we're trying to get you to understand, based on where you're at the periodic table, you're going to have similar properties. And the famous property for all of these guys is that they blow up in water. That has to do strongly with the fact that these guys all want to give up an electron. If you remember when we were talking about molecules just last week, if this guy loses an electron, he becomes really happy. So we lose this electron, and that's what causes sodium to want to bond with this chlorine, sodium chloride. But these guys really love blowing up in water. I shouldn't tell you this story, but I have heard of science teachers maybe putting too much sodium in the experiment, and then it ended up breaking the glass. And everybody was fine, but sodium is just one of those alkali metals that's a little explosive if you put it in water. So we're going to say explode when it absolutely. I am on camera right now, and we're joined by Ben. Say hi, Ben. Say hi, Ben.
Hi, Ben.
All right, go back upstairs. Thanks, bud. All right, that is Ben, and maybe I'll end up teaching Ben at some point. Wouldn't that be fun? All right, so alkali metals explode in water. Alkali earth metals, they're right next door. So they are the second column in. Column. It's that silent M and N that I always get wrong. All right, alkali earth metals, they are on period 2. Let's put for number 1, they want to lose 2 electrons. These like to lose 2 electrons. If you'll remember that this guy, oxygen, wants to gain 2 electrons, similar pattern. These ones over here, these alkali earth, want to lose 2 electrons. So what you'll end up seeing is this column 2 will really want to bond with this column over here, column 16. So because they want to lose 2 electrons to become more stable, it makes them better at forming bonds with elements. Magnesium is going to form magnesium oxide. So if we go over here, magnesium is 2 from the left. Magnesium really likes to bond with oxygen, which is 2 from the right. these guys are going to be shiny, silvery, and white. They're not as reactive. If I was to take magnesium and throw it into water, it's not going to blow up. But we already know that. It's going to have different properties because it's in this second column, not in the first column. So magnesium is silvery. I actually will end up burning it for you later on when we do our chemical reactions. It's pretty cool. So we're going to type that right here, silvery and white. Silvery and white and non-reactive. Okay, actinides. Actinides. Those are these ones down here. So these are at the bottom of the periodic table. These ones, oh, darn it all. These ones are very radioactive. These are very big elements. So we're going to go through and we're going to write here actinides. These are at the very bottom of the P table. These ones are known for being, well, used for nuclear reactions. Uranium, which is in atomic weapons, is an actinide. They are very big. So let's put very big nuclei, very big nuclei. For example, uranium has 92 protons and 146 neutrons. So it's uranium-238. So we're just going to say pretty big atoms, the biggest that we have. Our last but not least are going to be our halogens. Our halogens are going to be on this almost the far right. They're right here. These are the ones that all they can think about is getting one more electron. So we've got this pattern right here. And these guys are very reactive. I like to think of them as poison gases. They kill lots of the things that could cause diseases. So, for example, if I take iodine and I put iodine on my cut after surgery, it kills infections and things that could hurt me. Well, iodine is very reactive. Iodine is right over here. It's number 53. You guys have been to pools. Everybody knows, if you've been to pools, about chlorine. Chlorine is that very distinct smell. So we've got chlorine gas. It kills germs. And that's why these halogens are used. We've learned, hopefully by the time we've watched this, you've learned about functions, which is what something can do. But the function of these guys is to kill microbes, to kill disease, and to kill anything that humans wouldn't want. That's why iodine is used after surgery. That's why chlorine is used in swimming pools. That's why fluoride, you probably, when you were a kid, took some sort of fluoride or had fluoride in your water to help keep us strong. Guys, this has been basically a discussion about periodic table of the elements. I hope that you've gotten something out of this. Halogens we need to write down. They are killer of bad things. Halogens sometimes are gas, and sometimes can be liquid. These ones really want to gain one more electron. You're a great group of kids. I'm happy to be your teacher, and I'm even happier that you can learn even though I'm not here. Have a great day, and I will see you later.